So let's start solving some problems. And well, we have a passenger ship that just lets a shuffleboard cube push a shuffleboard disk, and it has a certain mass. And it's gonna be this. It's gonna be the mass, and it's gonna slide for 8 meters like there before it stops, and it has an initial speed of 5.5 meters per second. Okay, so we need to find the kinetic friction between the disk and well, within the deck and the disk. Okay, so we need to find these over here. So okay, let us first find the acceleration, which with this thing just stops. Okay, so I get a distance and I get a speed. So just like by thinking a little bit of it, I know that I can use this formula that says like the final velocity squared is going to be equal to the initial velocity squared plus 2 times the acceleration delta x. Okay, so from here we know that well, the final velocity is 0. The initial velocity, we know it. I'm gonna leave everything in formulas, so that's like far much easier for me to manipulate all the stuff. Initial velocity squared plus 2 times the acceleration. Uh, Final x, we know it. It's gonna be 8 meters. Once again, I'm gonna leave it as a variable, and I'm not gonna use it for now. And the initial distance is 0. So if I solve for either, I'm gonna be left with minus the initial velocity squared over 2x. Okay? It's negative because it's going on the other way in which the disk is moving. Okay? That's why it's negative. Okay? So for now, we're there. Now, I need the free to do the free body diagram. That's gonna be like here and here. Remember, something that's all over a surface, so it has a normal force that's perpendicular to a surface, it has a weight, and it has a friction force right over here. Uh-huh. Now, let me change colors for a nice blue. Okay, we need to do all the forces in x and in y. We do the sum of all the forces in x. What do I have in x? Well, I do just have the uh, friction force going on the negative way, and that's equal to mass times acceleration. And I also know that the sum of all the forces in y is going to be equal to the uh, normal force minus the weight, and it's going to be equal to 0. Okay, I should remember that whenever I find this kind of stuff, that's just like a horizontal thing, the friction is going to be equal to mu k times the normal force. Okay, so no, well, this is kinetic, yes, kinetic. Okay, so from here I just can substitute, and I'm gonna find that that minus the mu k friction force is gonna be equal uh, to the mass times acceleration. Okay. Uh, from this second equation over here, I know that the normal force is going to be equal to the weight. That means that that's equal to the mass times the gravity. Okay. So from there, I just can plug this equation right over here, and continue with my well, solving this stuff. I'm gonna find that minus mu k mass times gravity is equal to mass times acceleration. Okay, from there I know that acceleration is equal to all the stuff that's all over here, so I can substitute into this a that's over here, and I'm gonna be left with, well, and I can also notice that there's mass on both sides, so this mass dies with this one, and well, I just need to substitute, which will lead me to minus mu k gravity. It's equal to minus the velocity squared over 2x. This sign passes away with this sign, and I'm just left with mu k. It's going to be equal to initial velocity squared over 2x gravity. Okay, so if I just substitute the values, I just need to see that this is 5.5 squared over 2 times 8 times 9.81, and this is going to be equal to 0.193. Okay, coefficients do not have units, so just leave it that way. Okay, so this is my answer.